Hello, my dear students. I welcome you back to the session on Big Data Analytics. In our previous session, we were discussing this slide about the big data and the Hadoop concepts, and in which we discussed that opening up a huge file requires huge amounts of storage space and a lot of RAM also for processing. And we also discussed that big data files are very big in size, and a minimum size of a big data file is 1 TB. Okay, so what does the Hadoop technology provide us for files such as this? Number one, it gives us a distributed file system for storage of files, a distributed file system. Then it also gives us an analytics algorithm which allows us to perform analytics on the file. So guys, what are we going to learn? We are going to describe the big data, which we have already done. Then we are going to list out the limitations of the existing solution, which means that the existing database management tools are not sufficient to store, process and analyze this huge amounts of data which we call as big data. And the limitation in the analytics of the data is there. The time which we are going to have is huge if we use the existing solution, that is the database management system. Now what we do is we will define Hadoop and its components. Since we are going to learn Hadoop, we will define it along with its ecosystem. Now this ecosystem is all the components which are there in the Hadoop framework. Okay, and then we will also discuss that how Hadoop solves the limitations of the existing system, existing problem. Okay, so let's have a historical preview of big data, how this big data came into being. Okay, so in the year 2002, Google was faced with the problem of storing huge files automatically on its servers. You see, you are using Google on a, I won't say a daily basis, I think on a hourly or a minute to minute basis. You require some, some solution, you require some answer, any problem, you just first Google it. So Google itself was facing this problem about, how to store these huge files automatically on its servers. To solve this problem, Google wrote a white paper known as the Google DFS. Okay. White paper is usually, something related to the technicality of a problem, so as that the problem is stated and the solutions are, sought from the various people, the technical teams, the vendors, the sellers, the software companies. So usually a white paper is a problem area and for which solutions are sought. So Google wrote a white paper, Google DFS. It stands for Google Distributed File System. Now duck cutting. Duck cutting is a person who is a search framework developer. He designed the Lucene search engine. He was also working on the distributed file system at that time. So you see, Google had a problem with the automatic storage of huge files on its servers. For this, Google wrote a white paper, Google DFS. Duck cutting, who was a Linux, a framework developer, he developed the famous Lucene search engine. He was also working, excuse me, he was also working on the distributed file system. So what Yahoo did was, Yahoo hired duck cutting in 2002-2003, and duck cutting took 2 years to fully implement this distributed file system and named it as Hadoop. Okay, so the problem of the distributed file system, which Google, expressed through a white paper, was solved by duck cutting, who was hired by Yahoo in the year 2002 and 3. And duck cutting took 2 years to fully implement this distributed file system, and he named it Hadoop after his son's baby toy elephant. Okay. And then Yahoo implemented Hadoop as a framework in its full-fledged production environment. That means all the aspect of this Hadoop technology was tested in a full-fledged production environment. And later on, Yahoo donated this to Apache. Now Apache is a freeware, system or society where you get softwares free of cost. You don't need to pay for any license. And so it became a full-fledged project on Apache after Yahoo donated it to Apache. So with this we understand how the storage part of huge data was resolved, how huge files could be stored easily. So the solution was through a distributed file system, which stands for DFS. Now let's continue this historical preview. Now sir, Google solved this problem of saving of data. The next problem was to perform analytics on it. Okay, how to analyze this data for the business or the enterprise growth. So Google published another white paper known as Google MapReduce algorithm. Okay, and duck cutting and Yahoo again implemented this into its own solution as a full-fledged production environment and donated it to Apache as a full-fledged project. So the problem of analyzing of data was again taken up by Google publishing a white paper known as the Google MapReduce algorithm. And again, duck cutting in Yahoo, they implemented this into their own solution as a full-fledged production environment, and later it was donated to Apache so that everybody could use it. Okay. So let's have a small understanding of things, that what actually Hadoop is and what it does. Okay, so as we know that big data is about 1 TB or more of data. So Hadoop helps us to, number one, save this file. So it gives a distributed file system to us, which is also known as the Hadoop distributed file system, or in short it is known as HDFS. Okay, and the second thing that the Hadoop helps us is to perform analytics on this data, and for this Google gave us a MapReduce algorithm implementation. Okay, so let's now we'll be coming back to the components of Hadoop, and we'll discuss component one by one, all the components. Let's discuss a few things which were there in the earlier slides, which we just mentioned briefly, and now let's discuss them with some detail. So we had some discussion regarding structured versus unstructured data. So see, till the year 2000, relational databases solved the problems of data processing. Okay, so we had something known as a relation or a table in database management system. So you could store information in relations or tables, and you could process the information, and you could analyze something so that businesses can grow. But with the advent of the these social networking and the e-commerce sites such as Facebook, LinkedIn, Twitter, WhatsApp, along with it came the concept of unstructured data. Till the time we were using the relational databases, the database management systems, we had data in the structured form. That is, we first created a table, we defined all the things, and then we carried out the analytics or the processing on the data. But with the data size increasing and data coming in every shape around us, nothing structured about it. So along with it, along with this Facebook, LinkedIn, Twitter, WhatsApp, came the concept of unstructured data. So here is a small comparison between structured and unstructured data. So structured data is what a table looks like. A table would mean that we would first define, for example, if there is a information about student, so we would write roll number of the student, name, father's name, date of birth, marks, city, and so on. But in an unstructured data, audio files are there. Audio files could be a recorded audio file, a recorded audio would be there, or an impromptu audio would be there where a person is just recording simultaneously and sending the file to somebody else. Video files are there, images are there, chats are there. So all these things don't have any structure associated with them. Okay. Whereas in structured data, we have a table, we have rows and columns, we need to know what type of data types are there. And obviously structured data is much easier to handle as compared to unstructured data. Okay. So the problems with unstructured data is that it has got no structure, size is very big, and it is growing at a very fast pace in today's world. Now, since big data was a hot topic around those days. So everybody was chipping in with their own, idea what the definition of big data. IBM also gave a definition of big data. IBM, as you know, is the international business machine. It's a big company, and so they came up with their own definition of big data. We had one definition in the beginning given by the Wikipedia. Now we have a definition of big data of IBM. Now IBM views big data as some V's. Okay, so initially they had three V's of big data, then came the fourth V, and then the fifth V. So I'll just tell you guys what these V's are. Okay, so initially we had 3 or 4 different parameters around which this definition of big data was created. So we had one V as variety, one V as veracity, one V as velocity, one V as volume. See, so the volume is a V of big data which tells us that huge amounts of data is being generated. Velocity means that the data is being generated at a huge speed, it's being created on a per second basis. Variety is that the data is coming in every shape: audio, video, text, messages, pictures, videos. It's very difficult. There is no structure associated with data. So a lot of variety of data is there. And then veracity. Veracity is the truthfulness of data. That whatever data we are getting, how much out of that is good and how much is fake. You see, in today's world, a lot of data is being generated on so many things that you guys are using. Twitter, then Facebook, then WhatsApp. So many things are there. But you'll understand this thing that majority of the information that you get out of the air from these sites is fake. Okay, so IBM said this feature as veracity, a V of big data, which will ensure that we are dealing with true data and not with fake data. And recently one more V has been added to this IBM's definition of big data. That V is the value feature. Okay, that how much valuable is this data to an enterprise or to a business or to an organization or to an institution. So we can have safely, we can say that there are 5 V's of data: volume, velocity, variety, veracity, and value. And if we take care of all these 5 V's, then big data can be defined ideally. Okay, so because just having some huge amounts of data won't make it big. It must have some value, it must have some variety, but it must have some velocity also. And volume obviously is going to be large. Okay, so this was so far as the IBM's definition of big data is concerned. So another point which came up in the previous slides was the limitations of the existing solution, that is the database management system. So, or we also call it as the data warehousing. Okay, number one is the fixed schema of RDBMS. That is, you must first define a schema, only then you can have data. Okay, data cannot be built just instantly. Secondly is the cost factor. All the providers, these database management systems, you need a license to run all these things, and they've got a commercial angle, associated with them. And whereas this Hadoop is, is an Apache product, so it's a free of cost software. Anybody can use it without paying any money as a license fee. And this RDBMS, it works on a sample or a portion of the entire set. That is, you cannot analyze the entire data. But in Hadoop, when we are analyzing data, then the entire data is analyzed. Whereas in RDBMS, only a sample or a portion of the entire data set is analyzed. Okay, and obviously RDBMS cannot save and access huge files easily because the storage capacity is limited. Usually we are having a 500 GB or a 1 TB hard disk on our systems, whereas the big data files itself are at least 1 TB in size. So storage is obviously an issue with the existing technology that we have in terms of database management systems. Okay, and it cannot perform analytics on unstructured data. For RDBMS to perform analytics, you require structured data. So that's all. We'll end it here today. I'll come up with more in my next video. Thank you.